It's chemistry and you are watching Chem Science.
In this video, we will understand what are carboxylic acids, the general characteristics of carboxylic acids, how do we make carboxylic acids, the molecular and structural formula of first few members of carboxylic acids, and then we will see the chemical properties of carboxylic acids. Let's start with the general characteristics of carboxylic acids. The carboxylic acids are homologous series having COOH as a functional group. Now when we say it is dash COOH means there is an R group bonded to COOH, that is R can be any number of carbon chain atoms. So if there is one carbon, then R is supposed to have just one carbon, or R can have a chain of two carbon atoms also. So COOH is the functional group bonded to a carbon chain. So they form a homologous series with a general formula CnH2n plus 1 COOH, or you can also say CN2H2nO2. Now how is that we will discuss when we will see the structural molecular formula of some of the organic or carboxylic acids. The functional group which is present, COOH, is also called carboxyl group. The first four members of the carboxylic acids are liquids and the remaining members are solids at room temperature. Let's start with the structures of few carboxylic acids, but let's understand here that we have seen the general formula is CnH2n plus 1 COOH. Now we'll understand that how come we can apply this formula to find out the molecular and structural formula of carboxylic acids. So starting with the methanoic acid, and when we say it is CnH2n plus 1 COOH, then here if methanoic acid, if we say, then meth means one carbon atom which is already there in the carboxyl group. So in that case the N has to be 0. So in that case we will just end up with one hydrogen, and the formula of the methanoic acid will be HCOOH, or in short you can also write it as HCO2H. Now if we draw the structure, then the carboxyl group is having a C double bond O and bonded with one more oxygen which is in turn bonded with hydrogen, and that's why we call it as COOH. And if it's a methanoic acid, then the carbon is also bonded to one hydrogen, fulfilling all the four bonds or covalent four bonds of the carbon, and this is how we have methanoic acid. Now we need to understand that methanoic acid or any carboxylic acid, if we say, then the meth includes the carbon of the carboxyl group. So here if it is methanoic acid, then we already have one carbon in the carboxyl group, so we can't add any more carbon atom in the chain of this carboxyl group. The next member is ethanoic acid. Now eth means total two number of carbon atom including the carboxyl group. So here then N ends up with 1, and so we have CH3COOH. Why? Because if N is 1, then it is C1. H2N plus 1 makes H3. So CH3COOH, and so the whole structure can be drawn as carbon bonded to 3 hydrogen, the second carbon of the carboxyl group with one oxygen and double bond, and the other single bond OH. This is the full structure of ethanoic acid, showing all the atoms and all the bonds. The next member is propanoic acid, and prop means total of 3 carbon atom, which says N is equal to 2. So we have C2H5COOH when we apply N is equal to 2 in the formula or the general formula of carboxylic acid. So here the whole structure can be drawn as 2 carbon atom in chain with the carboxyl group, which I am drawing first here. Now the remaining 2 carbon atom, each of these carbons should have the total of 4 covalent bonds. So I'm drawing the 4 covalent bonds first, and now bond all this with the hydrogen atoms, which will give you CH3, CH2, COOH. So C2H5COH can also be written as CH3, CH2, COOH. So this is the propanoic acid. You can say this is the molecular formula, or this is the structural formula, or the structural formula you can say display formula, also showing all the bonds and the atoms. The next member is butanoic acid. Total of 4 carbon atoms. But gives 4 carbon atoms. So N is equal to 3 in case of carboxylic acids, making C3H7COOH as the molecular formula, or the structural formula you can write as CH3, CH2, CH2, COOH. If you draw the whole structure, then 3 carbon atom in the line bonded with the carboxyl group of double bond O, single bond OH, and all the carbon having the 4 covalent bonds. So I am fulfilling that first and then bonding hydrogen atom to all these covalent bonds. And if you now count the number of hydrogen atom, you will get the same molecular or structural formula. So these are the first 4 members, and I think now you have got the idea that how to make the molecular and structural formula. So you can make this way any number of carbon atoms with the carboxylic acids and make your own molecular and structural formula. So now let's go ahead with the forming of carboxylic acids, that in what way do we make the carboxylic acids. And one of the most common carboxylic acid is ethanoic acid. Very common uses it has. So let's make ethanoic acid, and it is made from ethanol. Now we have seen what is ethanol in our earlier video of alcohols. Ethanol can be changed very easily to ethanoic acid by 2 methods. The first one is by oxidation in air with the help of acetobacter, or it can be industrially made by reacting the acidified potassium manganate 7 with the ethanol, which will make ethanoic acid. Now these 2 reactions we have already seen in the video of alcohols also as part of the chemical properties of ethanol or alcohols. So here in general we can write the equation as ethanol, you know, is CH3 CH2OH. Now that can be oxidized to ethanoic acid. This is the formula of ethanoic acid. Now you can add oxygen, as I had mentioned earlier, as oxygen in the bracket, because it's not the oxygen which is directly reacting from the air as molecular oxygen O2, it's the oxidizing agent which is providing oxygen. So we write O in the bracket, and the byproduct is water. Now if you count, the total number of 2 oxygen atoms are added, so we can balance it by adding 2 in front of oxygen, and this is the equation which shows the presentation of any acid from its alcohol. Now suppose if we want to make a butanoic acid, CH3 CH2 CH2 COOH, then we need to use butanol as the starting material. Butanol in short can be written as C4H9OH, and the oxidation again can be written as O in the bracket, and if you see again the byproduct will be water, and again for balancing we need to add 2 with the oxygen. So this is how you can make any carboxylic acids with its respective alcohol by reacting it with acidified potassium manganate. So you can write H plus oblique KMnO4, which is potassium manganate 7 in short this way, because H indicates the acidification of potassium manganate, and this is how you can present the reaction with the catalyst. Let's start with the chemical properties of carboxylic acids. Now, as carboxylic acids, the name indicates ethanoic acid or any other acid, it is an acid. So, it is going to show all the typical acid reactions. Example, the solution of ethanoic acid or other carboxylic acid is going to turn the litmus paper red. Also, a solution of ethanoic acid contains H plus ions. Because it's an acid, it should have an H plus, that is hydrogen ions, and some of the ethanoic acid in the water is going to dissociate to produce these hydrogen ions. Now, as we have taken an example of ethanoic acid. The formula of ethanoic acid I'm writing here, and in short I'll write a reversible reaction to show that this is an acid which is going to dissociate into CH3COO minus and the hydrogen ion. Now, the hydrogen ion which dissociates is the hydrogen ion which is bonded to oxygen atom in the carboxyl group, and this is therefore called a carboxylate ion. Carboxylate ion, here we can call it as ethanoate ion because it is ethanoic acid, but in short or in general we can call it as carboxylate ion, and it dissociates into ethanoate ion and hydrogen ion. Now, why have I written a sign of reversible reaction? The reason being is that only some of the molecules of the carboxylic acids is going to dissociate into water and not all. Because it doesn't dissociate fully, we can't write a reaction which is full. So we write reversible sign to show that it's an only partial reaction because only few molecules dissociate. And since only some molecules dissociate, we can say that the ethanoic acid or any other carboxylic acids are the weak acids because it doesn't ionize fully. And as we have already said, it shows all the typical acid reactions. So ethanoic acid is going to react with the metals, bases or carbonates just like other acids to form the salts and the remaining products according to the reaction. So let's understand that in detail. Here we have taken an example of ethanoic acid itself, but the same reactions, similar reactions are shown by any of the carboxylic acid where the hydrogen ion bonded to oxygen is going to dissociate and is going to show the typical acid reactions. So starting with the first reaction, say an acid reacts with a metal, example magnesium. Now, as we have seen in our earlier videos of acid reactions, then all the acids are reacting with a metal where the hydrogen of the acid gets displaced by the metal. So if H gets replaced out, we have CH3COO, and in place of H we'll be writing magnesium because this is how the salt is formed by an acid. The hydrogen of the acid gets replaced by the metal. But as we know the valency of magnesium is 2, then the formula of the carboxylate ion, that is ethanoate ion, will get 2 and the hydrogen will be released. Hydrogen gas will be released. So here if you write a full balanced reaction, we'll get a 2 with the carboxylic acids. Going ahead with the next reaction, say an alkali like sodium hydroxide, or we can take any oxide, metal oxide also, suppose sodium oxide, it's going to show a similar reaction, but let's take only an example of hydroxide, metal hydroxide, sodium hydroxide. Now, as I said again, the hydrogen of the carboxylate ion, carboxylic acid, will be replaced by the metal. So H is replaced by sodium. So H is replaced by the metal and this hydrogen goes out, reacts with the hydroxide forming the water molecule, and so here the sodium salt of the ethanoic acid is produced. So if we name such salts, then we have sodium ethanoate. Sodium ethanoate is the name of the salt, sodium ethanoate. So similarly here we will have magnesium ethanoate. This is the name of the salt, magnesium ethanoate. If the carboxylic acid is some other acid like propanoic acid, then we'll name it accordingly, like magnesium propanoate will be the name. If we take in metal oxide, still we'll get the similar product of a salt and water only. Let's go ahead with the third reaction, say carbonate. Calcium carbonate is what we want to react with the acid here. So calcium carbonate, as I said again, the hydrogen of the acid will be replaced by the metal. So here metal is calcium, so we'll write calcium ethanoate, but again the formula will get 2 here because of the valency of calcium, which is 2, and the byproducts will be carbonate, carbon dioxide and water. So this is how the reaction is going to proceed, producing calcium ethanoate as the salt, calcium ethanoate. Now this shows that you need to understand the formula making of the carboxylate salt also, because depending on the type of the metal we may get the formula with different salts every time. And as carbonate produces carbon dioxide and water as a byproduct in the normal acid reaction, so here also the same reaction is going to occur. The next reaction is very important, which we will learn in detail in our next video also, but let's summarize here. Carboxylic acids also reacts with the alcohols. Now suppose if we say alcohol here as ethanol, ethanol reacts, it reacts in presence of any dilute acid. So I can write H plus also. Generally for acidification we use sulfuric acid, dilute sulfuric acid. Here I'm just mentioning it in general with H plus. So ethanol or any alcohol reacting with carboxylic acids produce esters. This is a very important reaction which we will learn in detail in the next video. So other 3 reactions are a general reaction of all the acids, typical acids which we have summarized here, and I hope all other parts of this video will be very clear about the general description and the properties of carboxylic acids.